And next, we'll hear from Marcel. Great. Marcel Strobel comes to us from Quantica, and he'll be talking about beyond thin layers, high viscosity solutions for printed electronics. Thank you.
Thank you for having me here. Who's this? Cool. So this will be a little bit an, oh, it doesn't change, an unusual presentation because I have to ask you for something. At first, I have a little bit of history in PCB, and I never got the idea why PCBs are called PCBs, printed circuit boards, while getting produced subtractively. But I got it, okay. These are photochemical printing processes, but nothing is additive in the past. So it was always my desire since 30 years to make a printed PCB becoming printed, additive. I built most of the water treatment plants for the PCB manufacturers in whole Europe. And I can tell you, you don't like to see what kind of mess they are producing every day, polluting the environment and throwing tons of money away because of copper is just expensive, and not only the copper. So it was always my desire, PCBs has to get produced additively. And I discovered a PCB is multi-material. There are a couple of applications that you could use to apply one of the needed materials, but there was no multi-material approach so far. I know there are some for some different kind of applications, but there hasn't been one application or one solution to print a PCB in just one production step. And those are capable to do somehow something in producing a PCB additively. Those aren't digital production steps. Means you have to strive for mass production from the beginning on, and this kills every project. If you have to ask for mass production, no one is going to pay you because the risk is way too big. Means it will only prove itself if it's capable to become digital for the sake of producing in a fast way prototypes, as Carlos did. So if you have a look into all the technologies at the end of the day, and I'm sorry to say this, I haven't invented it, inkjet is the only solution that is capable to do both. Multi-material means printing multiple materials in one step into one and the same object in a digital way. And unfortunately, inkjet got burned 10 years ago. Why? And I have also to say sorry for this. The print heads haven't been capable to print the materials. Those are needed to produce reliable PCBs. But fortunately, the world has changed. But once again, down to the problem. AME failed utilizing inkjetting because of the limitation of the print heads. And the limitation of the print heads caused limitations of the materials. Give you two examples. Take a conductive ink. If you can print only very low viscose materials or very low viscose inks, you have to have a lot of solvent inside of it. If you are printing particle-loaded inks, the particles has to be freaking tiny. If you are going to print dielectric material, the dielectric material provides the mechanical stability. If you can't print mechanical robust material, your PCB will not become mechanically robust. These are the constraints. So Quantica, not me, I'm not the founder and I'm not the inventor, I'm just the housekeeper. Quantica invented 6 years ago its own printhead, totally utilizing a different approach for the actuation. This led to a viscosity we can print up to 250 millipascal seconds. This number we have to talk very intensively about, and I will explain you what the meaning is of that, because this is factor 15. somehow to the rest of the market.